First one?
Hey, we're on, Alex.
Hey, it's Alex Williams of the New Stack here for another episode of the New Stack Analysts. This live stream catches up on you. You know that? Any case, we're here to talk about what to me is really an interesting topic on how these different orchestration platforms are starting to see kind of some ways that they really join together. So I'm here with Fritz Furstel, who is the CTO of NavOps, and Adrian Hall, an independent technologist and analyst and colleague of mine who I've known for many, many years. And so Fritz, we're going to talk about what you guys are doing with the Universal Resource Broker, because I think that does really reflect this concept of how these communities are kind of starting to see them, join in many ways. Tell us about the history behind the Universal Resource Broker that NavOps developed, what it does, and how it's being used.
So let's say for NavOps in general, we try to help customers make the most out of their Kubernetes cluster and avoid that they have to run multiple silos or stuff like that. So and in that notion also, Universal Resource Broker was developed because we were trying to help those customers bring Mesos workloads onto Kubernetes without having to run, let's say, a Mesos silo next to their Kubernetes installment.
Why were they wanting to bring it over?
We have been in touch with Mesos customers who wanted to join the Kubernetes bandwagon,
right?
Who had some issues with Mesos, let's say, or who liked some of the integrations that live on the Kubernetes side, some of the tooling, and so that's their motivation, really.
Okay. So you started developing it for these customers who are looking to...
We actually developed EURB originally for one of our other products. So we have a scheduling system, workload management system that is in the high performance throughput computing domain.
Right.
And EURB was originally developed for that. But since we have, for NavOps, transported some of our know-how into the Kubernetes world, we thought it's a good idea to do that for EURB as well. So we ported it over to Kubernetes last summer and open sourced it in that process. And that's more or less the background to EURB.
So Agent, what would be your questions about this kind of resource broker and how it applies? Because it does reflect how companies are using different service broker environments. Even service mesh technology kind of comes to mind when you think of this.
Mm-hmm. Well, I mean, some of the questions that come to mind too. Well, like you're talking about taking customers from Mesos to Kubernetes. Then there's been others I've talked to there, like on Triton. They're using that for container management, but then they're slowly in the process of moving it over to Kubernetes or something like that. And I keep reading over and over and over again that Kubernetes won, period. What's happening to the other ones in the first place? Are those communities growing? Are they shrinking? Like, are they going to continue to exist in 3 months, 6 months, a year from now? Is it just going to be Kubernetes? What's going on there too? Not just with the peripheral around Kubernetes. Like, is it bringing all those in, or there's still rogue entities that are growing? What's happening in those spaces?
I mean, at least on the Mesos front, what you do see is that people who got engaged in, let's say, the container management, or even previous to when containers become really popular,
right,
that engaged in the new wave of orchestrating the workloads, let's say in 2014 and 15, when Kubernetes wasn't quite a proposition yet.
Right.
They started with Mesos, maybe, right? And when they did that, then they still have a pretty good investment in it. Mm-hmm. And if they mostly run something like Spark, I mean, there isn't really a strong reason for them to migrate. Maybe they do at some point, but at this point in time, I don't see that happening.
Right.
It's different with the guys that started in 2016.
Right.
Right. Then it's a different story.
Yeah, you're only but so far down the road at that point, so you see the momentum and you probably just switch at that point or something.
Right.
And sometimes I think a lot of the other questions that keep coming up too, as I read these articles, and then whatever someone is using, whether they're using Kubernetes or something else, it's like at the end of the day, they're trying to deploy a service or an application that delivers some type of functionality to a customer. And even if they say they've deployed something on Triton, like I've worked with one company that did that, and they're still on Triton, and they're not even thinking about moving because they can put their containers out there. They don't have any problem. They don't see any need to change because their application is still getting deployed. And their primary concern is how easy is the container going to deploy? How easy can they build the new containers and manage that? So just their images and containers are all they're really worried about. So, of course, that's one use case. There's a zillion other out there. So, just always brings up the question of like what's actually happening to the ecosystem outside of this massive bandwagon everybody's gotten on with Kubernetes.
The guys who are really adopting Kubernetes big time are either the greenfield guys or the guys who are using even older technology. Let's say in financial services that had SOA technologies, and those get really rusty. And at some points they say, okay, we have to cut it, we have to switch to something new, and then Kubernetes is a logical choice.
Right.
Guys who have adopted Mesos, they aren't that bad off, right?
Oh yeah, by no means.
But then folks who are running Kubernetes, they may look at some of the Mesos frameworks and say, hey, that's actually something suitable. I can use that.
Right.
So why do I have to rewire that whole code and try to force it into Kubernetes?
Yeah.
When I can have something like EURB that just takes a Mesos framework and just runs it on it. Right? That's really the sweet spot, let's say, for EURB.
Yeah, definitely. I mean, you said SOA. That was like yesterday. I mean, I've already seen and heard work of like AIX and AS400 jobs getting containerized and brought over into environments. So that is definitely not just yesterday. That's years ago, and some of those are coming over. So I can imagine, even though here we are at KubeCon talking about Kubernetes and everything, there's still a vast majority of stuff that's running out there, and goodness only knows what. And I know a lot of groups want to containerize it, to bring over the modularity and isolation of that without needing to worry about the literally 30-year-old hardware or whatever that some of it runs on. They containerize it and they fix most of those issues.
I mean, we have customers in the enterprise space that have certified, really heavyweight, high throughput, specialized workflows, and they run it against this other product that I was mentioning, Univa Grid Engine, right? That is used a lot in the high performance and high throughput computing space. And what we have done in that context, if those customers want to use Kubernetes, we actually have containerized Grid Engine itself. So it runs as a batch workload service, basically.
Oh yeah.
They just can submit their non-containerized jobs actually against it. Still, the whole thing runs on the Kubernetes control. So from a control plane point of view, you have the Kubernetes view, and you have all the policies that we provide and so on to control that stuff. But you run your certified workloads. You do not have to recertify it. And in some cases, it's just not worth the effort to do that. Why would you want to?
Yeah, totally makes sense.
So how does it work? If I'm running, workloads in Mesos, and I want to move those workloads over to Kubernetes, how does the EURB work?
So EURB re-implements the Mesos API, basically the one that frameworks talk to.
Oh, so did you create an API to?
We created an API wrapper, so to speak. Mesos works differently from a resource allocation point of view than Kubernetes.
Right.
In Kubernetes, you submit a job that asks for whatever resources it needs, and Kubernetes allocates it to them.
Right.
A Mesos framework basically gets advertisements for resources that are available, picks from them, and tells it to the Mesos master.
Okay.
Now that's different
kind of a
allocation scheme.
Of the other.
Right. So what we did is, on the one hand, we co-opted the API of Mesos. So you actually the Mesos frameworks talk to our EURB master just the way they would talk to the Mesos master, and then we do the translation between those different allocation schemes. It involves some niftiness, so you have to do something like proxy jobs and stuff like that. But anyhow, in the end, the Mesos framework doesn't notice. They just see it
keeps working.
Yeah, exactly.
It was. That's cool.
So then the API kind of then reallocates those on a Kubernetes cluster then?
Right, exactly.
Right. And so you can point to the specific cluster that you want it to run on?
Yeah, absolutely.
Right.
Yeah.
And then you're running it and then it runs in a pod basically inside Kubernetes.
Right. If you look at how these frameworks look like when they run, right, they just look like regular Kubernetes workflows. So you have Kubernetes pods. You can manipulate them with kube control if you want to. You can inspect them, all those things. So there's no difference from that perspective.
So do they get allocated to with a container environment then?
Absolutely.
Right.
Yeah.
Right.
So
right.
in this case, we do not support non-containerized Mesos frameworks.
Right.
Right. In this case, they have to be containerized.
They have to be containerized. Yeah. Okay. And so that I don't expect that will change, will it? Will that change? Will you?
No, not necessarily.
Doesn't make sense why you would. Right.
I mean,
right.
It's actually a benefit to run them containerized because again, you can have the Kubernetes control plane. You can have like cAdvisor monitoring them. You can have all the reporting tools. I don't know, Datadog or whatever to dig into them and analyze.
To monitor them and
exactly.
yeah. So, is there, in terms of containerized workloads on Mesos? What does it look like out there? Is it? I would imagine post 2015, 16, you start seeing that. So is there a large customer base out there? People are running containerized workloads?
If you talk to Mesosphere, they would tell you that Mesos is the premier, or DCOS, let's say, is the premier environment to run containerized workloads.
Right.
So there's lots of that out there.
Yeah. So if they're pitching that, there is.
Yeah.
So then you pull those over. Then now, are they interchangeable? I mean, can you run them back through Mesos if you wanted to?
Yeah, absolutely. I mean, the framework doesn't change at all.
Yeah.
Right. So.
Right. It's just a framework.
Yeah.
Right. So what does this say to you, Adrian, about what we're seeing kind of with this whole kind of like capability to work between different platforms, and that's where I think service mesh becomes an interesting topic to discuss, and we're seeing lots of different discussions around service mesh technology. I imagine that's something you guys think about as well. But Adrian, any
what service mesh technology do you utilize right now?
None right now.
Oh, okay. Well, so I haven't looked at any that works with Mesos. I've only started looking at it and even toyed around with anything that works in the Kubernetes lane.
Right.
So it's a new thing for me to play with myself. Most of the time it's been a thing selected within architecture to use, and then I get the benefits out of it. So I've started playing with a few of the technologies. I'm trying to think of the Envoy is one of the ones that I haven't played with and I just learned about here that I want to look at. But each of the ones has different little features that I want to work with. But I haven't done that much outside of speccing it out in architecture, ensuring that it's there so that we can have the features that it enables for the overall.
Maybe we need to back up a little bit, because in terms of what you're seeing is like what you're doing is you're working between Kubernetes and Mesos, right? What is the what does that represent to you about how the market is shifting, or in terms of your technology architecture that you're developing for NavOps? Does it reflect at all upon how you want to build out kind of how you can optimize Kubernetes? I mean, your environment is pretty robust, and so I'm just curious on how this fits into that overall technical strategy.
The service mesh?
Thinking universal resource broker, but thinking, how you think of the context of services, being able to be portable, really.
And I guess one of the other things that comes to mind is like, how do you get observability into those loads once you transition them? Are you reliant on a service mesh in Kubernetes? And like how? I'm not sure what would have been used, like for, say the jobs are running in Mesos, then you guys pull them through, you're running them in Kubernetes. Was there observability in Mesos before? Like how does that move over? basically my question.
There are probably some tools, or there are certainly some tools that exist on both ends. So I think actually even like the monitoring tools and so on, you can actually run them, or I know you can run them because I actually seen those guys in conferences on both sides.
Well, I guess the key would be to, like, say you're, I don't know, Honeycomb or something. You'd probably just repoint it.
Right.
At whatever you want observability of. So if you once you move the jobs, move the containers over, then you're just going to repoint. It's not like you move the configuration of the observed management of things over. You just repoint it and look at the new stuff and say this is life now versus wherever it was.
I mean, we have had customers who have been asking, hey, can I live migrate that?
Right.
Which,
well, that's kind of what I was saying. Is like, so if you, I mean, depending on the solution, I guess there's probably different ways to fix it. But when you shift, going from one to the other, I mean, you're looking at a completely different networked environment with the containers. So whatever you were looking at, can't imagine it would just map one-to-one from your monitoring or whatever you want to call it, cleanly. Like you definitely want to say like, well, my pods are now set up differently with XYZ containers on them versus whatever the Mesos environment is running. So
right now, I mean, we're not trying to make that part completely transparent, right?
Yeah.
I mean, it's definitely is a paradigm shift. It is for customers who say, okay, I do have these Mesos frameworks. I actually want to use Kubernetes. I do have these Mesos frameworks. I want to continue using them, maybe even only for a certain period of time until I have rewritten stuff that I want to be native Kubernetes. That's possible, right? Or I want to use it forever. But it is a paradigm shift, so we're not currently supporting anything that would just transparently get things over from Mesos to Kubernetes, and you don't even notice that something happens. Let's say as an observer standing outside. Right.
Okay.
That would be interesting, but let's say a little bit complicated, and I don't know whether the market for that is big enough to justify the investment.
Yeah, it seems that might be pushing the nth degree of return.
Are those containers replicated in Mesa in Kubernetes when they move them over, or they just are like they move them out of Mesos into Kubernetes?
What do you mean by replicating?
I mean, are the containers just moving over and then they're out of Mesos essentially?
The customers would typically go and say, okay, I'm actually moving that service over from
just they're moving out.
Kubernetes.
Right.
It would actually be moving out.
Right. Okay.
So kind of a migration versus like a dual.
It's a migration.
Like you're not running in parallel.
Right. I
guess you could though, right? I mean, it doesn't turn it off for me. It just takes what was and moves it over.
Let's say you put a load balancer or something like that in front of it for some time because you want to test it. Of course, you can do that.
So this comes to the point where the customers really have to think about the tools that they're going to use in this new, as they migrate it over. Are you seeing any patterns?
No, not really. I mean, it's the patterns, I guess, or the tools are determined by what customers want to do in the end with Kubernetes. It's less about this migration dictating them. It's about how they want to set up and operate their Kubernetes environment.
What's been the interest in it?
The interest actually has been quite good from the standpoint when we open sourced it. So the EURB previously was closed source, and that had a few challenges. But since we open sourced it, there's a lot of interest and people trying it out.
So what's the next? So again, what is the next iteration of it? What will you be doing with EURB going forward?
One continuous challenge is actually keeping up with Mesos. They respin quite often and change APIs and stuff like that. They do? Yeah.
More so than other providers, do you think?
Let's say less so than Docker, but...
yeah, that's not saying much.
Yeah.
No, but it is a bit of a challenge to keep up with that. And the other thing is Mesos recently has added what they call HTTP framework, so where the interface is not Python C, but it's HTTP. So that's relatively new. That's something that we need to implement. That's probably the next few steps.
Great. Great. So where does this bring NavOps? Well, how does this fit into NavOps evolution as from a technical perspective?
Yeah. So as I said, actually in the beginning, the overall vision of NavOps is really to allow customers to make the most out of a Kubernetes cluster, to avoid that they have to fragment their resource pool, but they can actually keep it within a tight control. And it just adds the aspect of adding workloads such as Kubernetes without having to go through a lot of rewriting cycle. And as I mentioned, the same goes for non-containerized workloads. The same goes for workflows, which we support.
So what does that fragmentation look like? And tell me what kind of examples of fragmentation?
Yeah, we're in touch with a financial services customer that, for instance, said, okay, I have 16 projects. And then I have 6 steps in my project, like development, test, canary, whatever, right? 6 different stages. And they actually were planning to set up 6 times 16 Kubernetes clusters for that. 96 clusters. Now you can imagine that these 96 clusters are all but optimally utilized.
Right.
Actually, more likely they are like utilized in the 1-digit range most of the time.
So these are 90-something actual clusters, not like namespace divided or anything like that. Just full on
96 clusters.
Yeah,
that was the plan.
That seems an interesting plan.
Right, and people do that, I think, because let's say in the previous life in like financial services, they were maintaining those monstrous environments.
Oh, right.
And the admins actually had to be in control of it and had to get into a debate with the end users where you cannot do that, you have to do that, etc., etc. And they tried to get out of that with like a self-service type of scenario, which, okay, you get your Kubernetes cluster, do whatever you want.
Right. And that makes sense too, because there was the situations where
to some extent it does, absolutely.
Yeah.
Right? But if you then go, okay, I have 96 clusters, let's say every one of them is, I don't know, 50 nodes. Right?
Oh, right.
And
I only say makes sense in the sense of that was what they were doing, so that was what they knew.
Right.
Not that was what should be done at all.
Right.
It's just, you get so baked into I requisition 10 because I have 10 environments.
Right.
It's like, no, get one and then figure out how it's utilized. The new resources get added to what you have and then continue growth with that.
Right. So from a cost standpoint of view, and also from like governance point of view, it is just a problem that is bound to happen. That at some point somebody will look at that and will, well, how much do we spend on that? Or let's go cloud with that, right?
Yeah.
And where things tend to explode. At some point, somebody gets a bill that is many figures and goes, what?
Oh, yeah.
And then the problem occurs when you say, okay, we need to consolidate that. And that's exactly what we're trying to help customers do.
Are you seeing that happen a lot in Kubernetes now, where there's a lot of it gets to this point where there's that kind of like fragmentation that becomes a cost issue?
It's partly on the brink of happening. I mean, there's customers out there that know very well what they're doing and are designing their systems properly. Those are like the early adopters that write around issues that occur in that context. I mean, they code themselves.
Right.
But if, let's say, just some enterprise goes, okay, I need to switch away from my, let's say, SOA-based environment. They don't have the engineers to plan that out properly. They don't have the engineers to develop all those workarounds. Mm-hmm. So they just go and adopt these types of things, and then run into that problem. And we're currently basically in the stage where those followers are starting to go into their production environments. Mm-hmm. So we're a little bit in between chairs. We see the stuff that can happen with the early adopters, but they work around it. And the followers are starting to get to that scale where those things become a problem.
Yeah, I've run into the same thing a lot, where not always that a group will decide to or have built multiple Kubernetes clusters, but a couple of companies that I've worked with, they'll build one, and even if they namespace split out things and kind of divide resources a little bit, they still they'll get themselves into a situation where they'll kind of just rip some stuff out of here and try to deploy it straight, and it's vertically scaled apps. So you have like a relational database and one app server, and it has to be that way. So it doesn't really fit into the containerized modular paradigm. And all of a sudden they end up with a situation where it's like, well, this app is eating up a ton of resources, and this app over here is not. So they have a cluster, and it's kind of split out, but they still have this like just complete misadjusted resource utilization. And sometimes it's impossible to really get that split out because they'll pull like an old architected app over, and it's tied to two things. So all you can do is literally scale up that container and kind of hack the container to be able to use as much processor and memory that it can or whatever. But when they can pull it apart, then usually you can use some tooling or some type of mechanisms like you guys' stuff and really start to get utilization more evenly spaced across resources. But that's kind of it's the dream for a lot of companies. A lot of companies, when they pull stuff over, it's like they get what they've got because that's how the apps are set up. So
it becomes a resource allocation issue that they face.
Yeah, it's something that we have seen in like technical computing 2 decades ago.
Yeah, I was going to say since forever in tech talk.
And it took that market some time to get to good utilization. But you know, in a typical tech computing cluster, you're running between 70 and 90% utilization. That's not uncommon. That's not actually. If you get much less, somebody is getting yelled at. Right?
Yeah.
So it is possible to do that
because you want to keep the utilization high.
And they have very diverse workloads as well, right? I mean, you have workloads that require huge memory. You have workloads that are parallel. You have workloads that are throughput, etc. And you run that all on one cluster. Yeah. So
just make sure that the resources that are free are the resources that are getting stuff assigned to.
It's just a huge game of Tetris, basically.
Yeah. That's a good way to put it. I like that.
Yeah, so that's interesting. I mean, that's going to be, we're starting to see that much more as an issue kind of across the Kubernetes community is the optimization of resources, right? Yeah. You know, because in some respects, there's a handful of customers who need considerable resources, right? They may have used something like, you know, just in terms of service mesh, right? Linkerd, right? Which is like, requires a lot of memory and a lot of CPU power, and now they just kind of rewrote it to, well, they wrote their own new service mesh environment called Conduit. Yeah. And that has a much smaller footprint.
It
which
seems
then
like most of it should. Yeah. Or should be able to at least.
Right. And it seems some parallels there where, like, you know, people are trying to come across this issue where you know, how do you manage these resources and do it effectively? Right?
I mean, one of the reasons why you may not see, or why it's not being something that's talked here at these shows day in, day out, is probably because lots of customers come from a VM scenario and they ran 1 VM per app, right? Yeah. Right. And, you know, that had utilizations of 7% or something like that.
But I think some of that too,
if they go to 30%, you know, they say, hey, victory. Right.
And I think a lot of that too comes from the crux of the VM situation where you're duplicating your whole operating system. Right. I mean, that's it. And so you have all of the operating system, and whatever comes along with it, no matter what, your app does. So your app probably needs like a minuscule bit of what that operating system actually provides. Right. And you flip around and you take containers, and you're talking about a slice of the OS effectively. Right. So you get all these things that are now, you know, you're isolating them to little chunks, and your OS is really just sitting there allocating resources to the split out of containers at that point. And that makes it a lot more available and efficient, or at least the possibility to be available and efficient in a lot of ways, versus the VM is effectively tightly coupled to one application or one thing at a time. And in this way, we're still kind of keeping that paradigm for the core OS, I should say core OS, that's a thing. But the primary operating system is still tied to one thing, but that thing just happens to be whatever's running a bunch of containers or whatever, and slicing out the kernel slice for all that stuff.
Well, that is the big advantage in containerization.
Yeah.
And of course you get the immediate gain, but if you're not, you have lots of moving parts then,
right.
And if you're not good at placing them, then you still lose a lot of headroom.
That does seem to be the challenge of this new frontier of containers and virtualized networking on top of the virtual network of the network.
What is that? What is that challenge, you think?
Well,
how would you encapsulate it?
Well, like in Kubernetes, we're talking about a whole new universe basically sitting on top of the existing universe we had.
Right.
Because we have the physical hardware, which has the physical network,
right.
And it's allocated whatever, IPs, OSI, stack, etc. Then you have the servers and the operating systems that are on those sitting there running somewhere. Right. And if we're super lucky, we have like containerized something or other, whatever, Kubernetes on hardware, like straight on the metal. And if that's the case, then we've ripped out a lot of what's in between nowadays, but a lot of the time that's not what we have. What we have is now on top of that hardware is something that then is running X number of virtual machines, and the virtual machines are then running another network tier and whatever communication levels for that, and then the containers derived from the container images on top of and in that network environment. And to make matters even more complicated, you have networking tiers that sometimes breach concern layers, and they talk amongst each other. Like the virtual, programmatically managed network may be talking to literal physical network devices that can't be programmatically managed.
It can get even worse, right? If you run virtual machines that run something like Mesos or DCOS, and then that runs Kubernetes.
Right, exactly. So I mean, the levels of inception don't actually stop anywhere. They stop somewhere at, well, now you've crashed everything.
Yeah.
But yeah, that's the thing though. I find myself a lot of the time whenever I'm giving a presentation, especially in any type of Kubernetes 101 thing or even Docker 101 type of workshop or session or whatnot, a lot of the challenge is to describe that basically what you're hearing, a lot of it will sound familiar. We're still talking about networking. We're still talking about instances of some slice of an OS or whatever. It's another layer of abstraction that's completely virtualized and can be managed programmatically, which is what the real benefit and achievement of this layer, this extra abstraction layer in computing is.
Right. So has this affected your own technical infrastructure to any kind of major extent? Because now you're kind of sitting in the middle of this being this, providing this resource broker?
Yeah, it does. Less so from the resource broker point of view, more from our traditional business, technical computing business. So we do see customers that have an interest in running their technical computing on infrastructure like we have been discussing.
Okay.
Which in this case would mean they would, let's say, use Kubernetes to manage the whole pool of resources, and then run things like our workload management system as a service, and then, for instance, run some big data applications on top of Kubernetes, and let's say run some web applications that they use for the internet things or for the customer also on top of that. So it becomes more of an integration point, which really bridges very different types of workloads, which formerly lived in totally different departments, even in those companies, right?
Mm-hmm.
They were not even talking to each other. I mean, we had cases where we went into our customers and said, existing customers of ours, right? Can you introduce us to the big data guys, or can you introduce us to the web application guys? We don't know them. But now we find customers that are looking at really consolidating those types of things.
Right. So now they're running kind of all together, in that Kubernetes environment, and they're treated as components.
I will say this is quite forward-looking, right? So there isn't too many people that you find of that nature, but they do exist.
Right. And so they're moving applications. They're turning out. They're kind of like transforming their applications almost into components themselves to some degree. Because if they're running in containers, right? They're creating services. A part of those applications needs to transition. Another part, like I've mentioned, can actually stay as it is. It just runs against the service that is containerized. Right. Well, this has been a great discussion. I really appreciate your time, Fritz.
My pleasure.
And maybe you could just tell, just some finale, tell people a little bit more about NavOps and, and where you are going in the next year. What is kind of some of the direction you want to take the company and the technology?
Right. NavOps is in general trying to add value on top of Kubernetes. We have a number of different aspects. We talked about EURB, we talked about the mixed workloads.
Right.
One of the key things we do is policy management on top of Kubernetes.
Right.
So really advanced policies.
Right.
And that's more or less where we're taking things further. We're working with customers on that consolidated vision that I've been mentioning just before we're discussing. And really the key thing is work with those customers, understand where their problems are, and feed that back into practical solutions that we can then redeploy with other customers. So I'm actually not a big fan of trying to inflict grand vision on customers. I'm trying to understand what customers want and
iterate,
build the product that solve their problems and use that for other cases as well.
Well, thanks, Fritz, and Adrian. Thanks for joining us today. It's good to see you, and
glad to be here.
Here in Austin, away from our homelands of the Pacific Northwest. But we'll look forward to getting together soon.
Yeah, for sure.
Thank you. Have a great show.
Yeah, thanks.
Cheers, Alex.
Thanks.